tree. It gives us A, B, C, D, E if we traverse it using pre-order traversal. And it also gives us the same sequence if we use in-order traversal. And it simply asks us to construct the tree, to draw the tree. I'll give maybe 1 minute for everyone to try to construct this tree. So we have 5 nodes, A, B, C, D, E, and the order of nodes being visited would be A, B, C, D, E for both pre-order and in order. And we wish to construct the original tree. I guess how we can solve this problem, one possible approach could be at the very beginning when we have these two sequences, can we know which is the root node of the entire tree? Looks like by looking at the pre-order traversal sequence, we can know the root node of the tree because if we apply pre-order traversal on a graph, we must visit the root node first. So node A must be the root node of the tree. And after identifying that A is the root node of the tree, maybe we can think about which nodes might be in the left subtree and which nodes might be in the right subtree. Now, looks like we can look into the in-order traversal sequence. So in-order traversal sequence gives us A, B, C, D, E, and we already know that A is the root node. And remember that the rule or the order of nodes being visited if we apply in-order traversal is we will first visit all the nodes in the left subtree, then the root node, then the right subtree. And since in this case, the root node is the first node being visited in-order traversal sequence, I think it tells us that we cannot have any node in the left subtree. Because if we have, for example, if we have an X node here as a left child of A, then in the in-order traversal sequence, we must have this node X being visited before visiting node A. And in this case, since we don't have any node being visited before node A, I think we can't have any node in the left subtree. So this tree can only have a right subtree. Now, if we want to construct the right subtree, I think we look at the pre-order and in-order sequence again. So the pre-order sequence gives us B, C, D, E, and we know B, C, D, E, all of them are in this right subtree. So repeat what we just did. Let's try to find the root node of this right subtree. And the root node is clearly, in this case, node B. And after identifying that B is the root node, I think we can also repeat what we just did. Let's try to figure out, can we have any node in its left subtree and some other node in its right subtree? Now, by looking at the in-order sequence, node B is the first node being visited after visiting the root node of the entire tree. This means that we cannot have any node as the left subtree of B. And the same reason, if suppose we have a node X here, then this node must be visited after visiting node A but before visiting node B. because it's in the left subtree of node B. And since in this case, we don't have anything in between A, B in the in-order traversal sequence, so we know that X node here does not exist. So we can't have any left subtree. So all the other nodes 3DE, all three other nodes CDE must be in the right subtree of node B. Now for node CDE, I think what we're going to do is, again, we try to identify the root node of this subtree and then follow the same process. And I guess it should be clear enough to say C must be the root node of this subtree. And again, we shouldn't have any left subtree of this node. Then we have node D and node E. So we're going to have the tree constructed as shown on my screen. A is the root node of the tree, and then it has a right child of B. B has a right child of C. C has a right child of D. D has a right child of E. And in this case, we don't have any left child in this tree. So generally, if we have pre-order and in-order traversal sequence of a tree, what we can do is we can recursively find the root node of a tree or a subtree. Then for the rest of the nodes, by looking at the in-order traversal sequence, we may be able to identify which nodes are in the left subtree and which nodes are in the right subtree. And then we repeat these steps recursively until we construct the entire tree. So this question is not too difficult when we only have 5 nodes. And let's consider a slightly complicated case where we have, that's about 10 elements.